This is the story of a dynasty, long forgotten. A king without a crown, without a throne, and without a rival worthy of its size. More than 27 million years ago, it was the largest creature ever to walk on land, and then it vanished without a trace. To uncover the truth, we must begin with something that seems almost meaningless. A fragment of bone, a piece of stone, a fossilized tooth. Buried underground for millions of years, a fossil jaw twisted like a curse still clung to a single tooth. And inside that tooth was a very different story. It wasn't just an inert shard of matter, it was a diary, a personal record of a life once lived. Tiny growth lines in its enamel, called retzius lines, recorded every day and every week. This giant survived on Earth. Scientists employed a groundbreaking technique, analyzing proteins and chemical elements preserved in the enamel. What they discovered was astonishing. The tooth did not only reveal what species it belonged to, but also when the young stopped nursing and switched to eating plants, how the animal's diet changed with the seasons, and even how its environment shifted over time. So what happened to the massive creature that owned this tooth? Why did one of the mightiest animals ever to stride across land vanish completely from the earth? This stone-carved diary holds the key, and it tells a story both grand and tragic, a story about life itself. To find the answer, we must return to the Oligocene, an epoch that stretched from 34 to 23 million years ago. It was a dramatic turning point in Earth's history. After the warm climate of the Eocene, when crocodiles lived as far north as the Arctic Circle, the planet underwent a powerful cooling event known as the Eocene-Oligocene transition. Global temperatures dropped by about 9 to 11 degrees Fahrenheit, triggering the growth and spread of glaciers across Antarctica. This climate shift was no mere backdrop. It was the central character reshaping every ecosystem. The lush rainforests and tropical woodlands of the Eocene slowly gave way to vast plains, grasslands, and open dry forests across Eurasia. Vegetation changed, and animals were forced to adapt. Dense jungles that once sheltered primates and countless specialized species shrank, while hardy plants like grasses and shrubs became dominant. In this changing world, a diverse community of mammals thrived. Sharing the stage with our giant were fearsome predators such as hyaenodonts and amphichionids, the so-called bear dogs, strange herbivores like entelodonts. The notorious hell pigs roamed alongside smaller, faster rhinos. The entire Eurasian continent had become a vast biological battlefield where every species was locked in a struggle to endure an increasingly harsh environment. And then there was Paraceratherium, a creature of staggering proportions. It shattered every limit of mammalian size on land. From scattered fossil remains, paleontologists reconstructed an animal that stood nearly 16 feet tall at the shoulder, stretched more than 26 feet from head to tail, and weighed between 30 and 40 tons. Its bulk dwarfed any land mammal alive today, 3 to 4 times heavier than a full-grown African elephant. An adult human would not even reach the top of its leg. Although the prehistoric elephant, Paleoloxodon namadicus, may have been heavier, Paraceratherium still stands as the leading contender for the tallest land mammal ever to exist. To grasp the magnitude of this animal, we must compare it with the other giants of history. Contrary to the image of a predator fueled by brute strength, Paraceratherium was in fact a gentle giant. Its low crowned teeth were designed only for browsing leaves and soft branches, not for grinding grass. Its power was not for fighting, but for defense. With its enormous size, an adult Paraceratherium had virtually no natural enemies. Only the calves were truly vulnerable, facing threats from giant crocodiles like Astorgosuchus, or from fearsome predators such as the bear dog relatives known as amphixionids. Yet a creature nearly unmatched in size and strength, a ruler of its ecosystem, did not survive into our age. That fact raises the ultimate question: why did such a mighty animal disappear forever? The journey of Paraceratherium was not an accident of nature. but the pinnacle of an evolutionary strategy millions of years in the making. Its lineage can be traced back to smaller, more agile rhinos of the Eocene, animals with long legs built for running. These early ancestors belonged to the family Paraceratheridae, once classified as indricotherium. Notable precursors included Foresticoperia, about the size of a large dog, and Juxia, comparable to a small horse. Over countless generations, each descendant grew larger, a textbook case of evolutionary gigantism. The anatomical changes were striking, where its ancestors had long, slender legs for speed. Paraceratherium evolved straight, pillar-like limbs. These sturdy legs could bear immense weight, but at the cost of agility. By then, the animal no longer needed to run. Its survival strategy had become simple: stand firm and face the world. Modern science has revealed even more about its biology. Analysis of growth lines in its tooth enamel shows that young Paraceratherium grew quickly at first, then slowed as they reached maturity. Much like modern elephants, females likely endured extremely long pregnancies, up to 2 years, and gave birth to only a single calf at a time. This meant slow reproduction and low birth rates, a common trait in massive mammals. While this ensured that each calf had a better chance to survive, it also left the population fragile in the face of environmental upheaval. The success of Paraceratherium was not built on violent power, but on specialization. It was a high browser, claiming a feeding niche no other herbivore could reach. Standing nearly 16 feet tall with a neck stretching 6 to 8 feet, it could easily strip leaves from treetops well above the reach of any competitor. To master this food source, Paraceratherium carried unique adaptations. Fossil skulls suggest it had either an elongated upper lip or a short, muscular trunk, similar to today's tapirs. This flexible structure allowed it to grasp and pull down branches. Its low crown molars, with simple ridges, were perfectly suited for chewing soft leaves and twigs rather than tough grasses. A typical day for this giant must have been slow and steady, wandering across sparse woodlands, stripping vast amounts of foliage to feed its immense body. Its size required enormous quantities of food. Yet in the stable forests of its era, the supply was abundant and virtually untouchable by other species. In a way, it had built its own ecological kingdom, a dominion founded on ultimate specialization. But the very traits that crowned Paraceratherium with glory also planted the seeds of its downfall. The Oligocene world, as mentioned before, was cooling and drying. Dense forests shrank, giving way to open grasslands and scrublands. For a browser that relied entirely on tall, leafy trees, this was a devastating shift. Its teeth were never designed to handle coarse grasses. Biological challenges mounted as well. Its colossal bulk created a constant struggle with heat regulation, the same problem faced by modern elephants. In a drier, hotter climate, shedding excess heat became increasingly difficult, and with a reproductive rate so slow, its populations could not recover from disasters, whether famine brought on by dwindling food or a sudden rise in mortality. The extinction of Paraceratherium was not a single catastrophe, but the outcome of many forces converging. Climate change delivered a relentless blow, reshaping the very landscape it depended upon. But the story holds yet another twist, an unexpected rival, waiting in the wings: the invasion from Africa. While Paraceratherium was struggling to adapt to a shifting environment, a new wave of animals arrived from Africa into the vast lands of Eurasia. The Gomphothids, ancestors of modern elephants. This was not a cinematic clash of giants, but something far more devastating: an indirect ecological war. Paraceratherium was a strict specialist, a leaf browser with teeth and a body suited only to one type of food. By contrast, the Gomphothids were mixed feeders, able to digest both leaves and grass. This flexibility gave them a massive survival advantage in an increasingly arid climate, where grasslands were spreading wide across the land. Studies suggest that Gomphothids acted like ecosystem engineers. Their feeding habits disrupted the vegetation, thinning out the sparse woodlands where Paraceratherium thrived, and turning them into open grasslands. In doing so, the Gomfathers indirectly destroyed the very food source upon which Paraceratherium depended. The battle was not for a single branch, but for control over the landscape itself. And in that battle, the flexible newcomers delivered the final blow to a giant already weakened by environmental change. The extinction of Paraceratherium was not the result of a single disaster, but of a perfect storm of multiple pressures. Imagine a line of falling dominoes. The first was global climate change. As temperatures dropped and rainfall declined, woodlands shrank and fragmented, reducing the only food this browser could eat. The next domino was the arrival of competitors, like the Gomfathores, who accelerated the decline of its habitat by reshaping it into grassland. And the final domino was the giant's own biology. Its slow reproduction, long pregnancies, and narrow feeding niche left it unable to recover. The death of Paraceratherium marked the end of an era for Earth's giant specialized herbivores. It was a sobering lesson. Even the greatest size cannot guarantee survival, especially when specialization turns into an evolutionary trap. When Paraceratherium vanished, the enormous gap it left behind was soon filled by smaller, more adaptable herbivores. Agile rhinos continued to survive and evolve. Most notably, the relatives of the Gomfathers' modern elephants would go on to become the largest land mammals of our age, dominating new ecological niches across continents. But the story of Paraceratherium does not end with extinction. It leaves us with a profound reflection on the limits of gigantism on land, and an unexpected comparison to the largest creature of all time, the blue whale. On land, the growth of gigantic size is restrained by two unyielding forces: gravity and the scattered nature of food sources. A massive body requires enormous amounts of food, but moving across vast distances to find it demands equally enormous amounts of energy. The extinction of Paraceratherium reveals the breaking point of this strategy. In the oceans, however, those rules no longer apply. The blue whale, the largest animal to ever live, achieved its size thanks to a similar environmental shift, but with the opposite effect. Roughly 4.5 million years ago, during an extended ice age, changes in ocean currents created nutrient-rich waters where plankton and krill gathered in vast, dense swarms. The buoyancy of seawater freed whales from the crushing burden of gravity, while the concentrated food supply allowed them to grow ever larger, evolving into the colossal giants we know today. The extinction of Paraceratherium marks the ceiling for gigantism on land, while the rise of the blue whale demonstrates how the ocean shattered that ceiling, allowing life to reach a scale unimaginable on solid ground. From a single fragment of fossilized tooth, we have traced the life of a creature that once stood as the pinnacle of its age. The story of Paraceratherium is a powerful reminder of the fragility of life, even for the mightiest of giants. Great size is no passport to immortality. So, could another land mammal ever grow to the size of Paraceratherium again? With today's accelerating climate change and shrinking habitats, such a possibility seems almost impossible in the near future. Perhaps Paraceratherium was the last land mammal to claim such a singular kingdom. Its story is both a tribute to a lost age and a prophecy of the natural limits that life must obey. Thank you for joining this dramatic journey into the rise and fall of a vanished giant. If this story has sparked your curiosity, leave us a comment below and share your thoughts. And be sure to subscribe, because in the next episodes, we'll continue uncovering more mysteries of the prehistoric world.